we will determine whether the given value is a solution to the equation or not. Why do we need to figure out if it's a solution or not? Well, that's so we could check our work. In order to figure out if x equals 7 is a solution to this equation, 5x minus 9 equals 26, we just have to do substitution. I need to plug in that 7 every single place I see an x. And when I do the substitution, I'm going to replace that x with a set of parentheses. Then plug in the 7 into that parentheses. We have 5 times 7 minus 9 equals 26 now. And we just got to check to make sure both sides are equal. 5 times 7 is 35 minus 9, and that's equal to 26. 35 minus 9, that's 26. So we do have 26 equals 26. So we know x equals 7 is a good solution. So yes, it's true. X equals 7 is a good solution. For part B, we're going to do the same thing. So take some time. Maybe you can try this problem on your own. M equals 4. You want to plug that in to each and every location you see an M. And when I substitute that M, I want to use a set of parentheses every single time I do the substitution. So give this one a try. Pause the video. Okay, so let's substitute the 4 in everywhere we see an M, and then we can simplify. According to our orders of operation, we always start with the parentheses first, then exponents, multiplication or division. These are done together from left to right. Addition and subtraction are done together from left to right. 8 times 4 and 3 times 4, these are not considered parentheses. When we say parentheses, we want to do the operation inside the parentheses. But since 4 is just a number, we're not adding or subtracting anything inside the parentheses. It's actually considered a multiplication. So this is actually a multiplying operation. It's not considered a parentheses when we're considering orders of operations. So let's multiply. First, 8 times 4, that's negative 32. 3 times 4, that's 12. And we'll bring down that 29. I can subtract 32 from 15. That gives me a negative 17 on the left. And on the right, we have 12 minus 29. And that's also negative 17. So that means m equals 4 is a good solution. Yes, m equals 4 is a solution to this equation. The next example is solve using a multiplication property of equality. What I want to do is I want to isolate that x. I want to get that x by itself, so I can say x equal to some number. Now there's a 7 in the front. And when there's a 7 in the front, that means multiplying. So this is saying 7 times x equals 343. I want to get the x by itself, so do the opposite. The opposite of multiplying by 7 is to divide. So we'll divide both sides by 7. And notice what happens. The 7 reduces to a 1, and that reduces to a 1. So we have x on the left side, and that's equal to 343 divided by 7, which I can simplify. This simplifies to x equals 49. And that's my solution for this question. I could also write it in curly brackets. And so that's our solution, 49. For part B, again, this is a negative 8 times x. So we are going to use the opposite, and that's division. We're going to divide both sides by negative 8. And so the negative 8 is reduced to 1s. We don't write 1x, we just write x on the left. And then we can divide 48 by negative 8. We can get our solution as x equals negative 6. Our solution is negative 6. And if we're not certain, we can always substitute that negative 6 back into the equation. Negative 8 times negative 6, that is equal to 48, so I could check my work for these problems. In part C, I want to solve for x, and here x is being divided by 3. What's the opposite of being divided by 3? Well, that's multiplying by 3. That's what we're going to do. Let's multiply both sides by 3 in order to maintain that equality. And so what happens here is I could put this over a 1, and look, we can reduce. The 3 divides by 3, you get a 1. The 3 divides by 3 on top, you also get a 1. So we get x equals, and now I can multiply 18 times 3. This is equivalent to 54, and that's our solution. For part D, I have a fraction in the front, negative 2/5 times x equals 4. So what I want to do here is to cancel out, or actually reduce, the negative 2 over 5 into a 1. To do that, we're going to use the reciprocal of negative 2 over 5. What that means is I'm just going to take this fraction and I'm going to flip it over. But since I multiplied the left side by negative 5 over 2, we have to do it on the right side to maintain that equality for the equation. Notice when we multiply now, we can reduce diagonally. So the 2 reduces to a 1, the 5 reduces to a 1, and the negatives, they become a positive. This simplifies now as negative 1 times negative 1 times x, or just a positive x, and that's equal to, well, I can simplify this fraction on the right, put it over a 1 here for the 4, reduce, 2 divided by 2 is 1, 4 divided by 2 is 2, so this is 2 times negative 5, so that's negative 10. X equals negative 10. For part A, we're going to solve this equation using the addition property. What that means is if we have A equals A, we can add anything we want to both sides of the equation. I could add a B to both sides and the equation will still be equal. I could also subtract B to both sides and the equation is still equal. So it doesn't matter what I do, as long as I do it to both sides of the equation, it will still be true. So in this case, we have A plus 9 equals 16. I want to get the A by itself, so I'll do the opposite. What's the opposite of adding 9? That's subtracting 9. So let's subtract 9 to both sides. And we have A is equal to 16 minus 9. And that is 7. So A equals 7. For part B, what's the opposite of subtracting 13? Well, that's adding 13. Let's add 13 to both sides. And so that 13 and the negative 13 cancels out. We have N equals 43. That's our solution for part B. And if I'm not sure on the problem, if I want to check my work, well, plug in that 43 back into the N and see if it's equal to 30. 43 minus 13, that is equal to 30, so I could always check my work if I have time on an exam. For part B, we're going to do the same process. I'm going to add 25 to both sides. And so the 25 and the negative 25 cancels out. We have B equals negative 6 plus a 25, and that gives me a 19.